This conference will now be recorded.
So in yesterday's class, we saw limit test for chlorides and we saw limit test for sulfates. The same way today we'll see limit test for iron. If possible, we'll try to cover limit test for arsenic as well as heavy metals. Okay, so for limit test for iron, these are the apparatus which is required. The same Nessler cylinder, glass rod and stand. The chemicals which is required here is standard iron solution, 20% iron-free citric acid, thioglycolic acid and ammonia solution. So I'll explain the procedure first. Please have a look at the procedure carefully. Okay, and then when I go to the principle, I'll ask you the procedure. Okay, so you're going to take 250 ml Nessler cylinder. As usual, you're going to label one as your test or sample and you're going to label the other as your standard. Now in the test Nessler cylinder, you're going to take whatever is the sample that you have been given and you're going to add 40 ml of distilled water and you're going to dissolve it. Later to this, you're going to add 2 ml of 20% citric acid solution and 2 to 3 drops of thioglycolic acid. Next, you're going to make the solution alkaline using ammonia solution. After the solution, the whole solution has turned alkaline in nature, you're going to make up the volume to 50 ml using distilled water. Next, you're going to mix well and allow to stand for 5 minutes. In this standard Nessler cylinder, you're going to take 2 ml of the standard solution of iron. Then you're going to add 40 ml of distilled water and the rest of the steps are the same as what you have done for the test. So the only difference will be in the first step. So in test, you're going to take sample and dissolve it in water. Here you're going to take standard solution 2 ml and dissolve it in water. That is the only difference. So in limit test for sulfates and chlorides, we compared the turbidity. Here we're going to compare the color of the test with standard. So look at the reaction here. So here you can see that iron which you are using is in the ferric form. So this ferric form of iron, that is Fe3 plus, will be reduced to the ferrous form by using your thioglycolic acid. This ferrous form further reacts with your thioglycolic acid to give you this complex which is called as ferrous thioglycolate complex. Now this complex is, the range of the color varies from pale pink to purple color. Okay, so what basically happens here is iron which is present in ferric form is reduced to ferrous form. This ferrous form of iron reacts with your thioglycolic acid, that is CH2SHCOOH. It reacts with your thioglycolic acid to give you a complex called as your ferrous thioglycolate. Now this is something I just pulled up. Is the image clear? Can anyone tell me, is the image clear?
Yes, ma'am.
Yes, ma'am.
Okay, so this is how it will look. This is your Nessler cylinder. Okay, the left side is your test Nessler cylinder and the right side is your standard. So remember, I told you that the color variation is between pale pink to purple in color. Okay, so this is what is the color of your standard solution of iron. So when the test is this color, what happens here? Does it pass or does it fail? The principle is the same, when it came to turbidity in case of your chlorides and sulfates, it's the same principle which is applied here, and you can see that the color of the test solution is almost colorless or maybe very, very pale pink in color, whereas the color of the standard solution is dark pink in color. So what do you think happens to this sample? Does it pass the test or does it fail the test? Yes, someone answer. Does it pass or does it fail? told previously also, if you don't know the answer, you can at least unmute yourself. Interactive, I'm say, ma'am, I don't know. So unless you people are going to assume that you people are not there in front of the Trish.
Ma'am, your voice is
Aisha,
breaking.
It's fake.
how about now? Is it clear now?
Yes, yes, ma'am.
Okay. So what happens to the sample here? Does it pass the test or does it fail?
It's failed, ma'am.
No, it passes. See, it is very clear. Okay. Now, here what happens is the standard solution color is very dark in color, right? Anything which is lighter to your standard passes. Anything which is darker than your standard fails. Okay, when it came to turbidity also yesterday for limit test for chlorides and sulfates, it's the same principle. There, if the turbidity of the standard is more and the turbidity of your sample is less, then your sample passes the test. But if the turbidity of your sample is more than that of the standard, then the test, it fails. Okay, this is the basic principle. So looking at the image here, the test passes here because the test solution color which is there, it is very lighter when compared to your standard solution color. Okay, is it clear?
Yes, ma'am.
So what is the principle behind this limit test for iron? It is based on the reaction of iron in ammoniacal solution in presence of citric acid, thioglycolic acid to form your ferrous thioglycolate complex. So as I said, ferric ion is reduced to ferrous ion. This ferrous ion further reacts with your thioglycolic acid to give you your ferrous thioglycolate complex. The color of the complex, as I said, ranges from pale pink to deep reddish purple. What we saw was dark pink. Okay, it can further turn into deep reddish purple, and this color, the color depends upon the amount of iron which is present in the sample. So this is the same, sample or test color is compared with the standard color, and the test passes if the color of sample is less than the standard, and the test fails if the color of the sample is more than the standard. So probably this you will understand better once you start coming here and start doing the practicals, and I'll give you around 3 to 4 samples to do the limit test. At that time it will be very much clear, but by this time you should have got an idea. So if the standard has a dark color and the sample has a lesser color, that means to say it passes. Now, we have added citric acid, right? We have added thioglycolic acid, 2 to 3 drops, and we have also added ammonia solution to make the solution alkaline in nature. Now, why have we added these 3 chemicals? Now, citric acid is added to prevent the precipitation of iron by ammonia by forming a complex with it. So basically, you are adding citric acid to prevent the precipitation of iron. So next, why are we adding thioglycolic acid? So this thioglycolic acid reduces the ferric form of iron to ferrous form, and then this ferrous form forms a complex with your thioglycolic acid to give you your ferrous thioglycolate complex. Next is we have added ammonia. So this complex that is formed, that is your ferrous thioglycolate complex, it is colorless in acidic or neutral solutions, and hence ammonia is added to maintain the alkaline medium in which the purple color or the pale pink color of the complex is developed, and it also helps in maintaining the stability of the color which is formed. Okay, so this is the reason why these 3 chemicals are used in the limit test for iron. Is it clear? Do you people have any doubts? Do you want me to go through this again?
No, ma'am, it's clear.
Okay, is there any network issues or is it clear?
Clear, ma'am.
Okay, okay. So we'll move on to the next limit test, that is limit test for heavy metals. Now, can anyone tell me what is heavy metals? What is heavy metals? Heavy metals are nothing but metals which has high density, which has a high atomic weight, and which has a high atomic number. Okay, and usually these heavy metals are toxic even at a very low concentration. Now, yesterday when I gave you the example of Maggi, what was the limit which I said was exceeded by the manufacturers of Maggi? What was the impurity or chemical that they had violated and told wrong that it is within the limits? What was it? Let me see how much you remember. Meghna? Komal? Yashwant? You all were present in yesterday's class. So tell me.
Monosodium.
No, that is MSG which they had told that they have not added, but they had added. There was something else, right, that exceeded the limit because of which it was banned.
Ma'am,
So
lead.
what is that? Lead. Yes, correct. Prashant is correct. Okay. So yes, it was lead. Okay. So lead is nothing but your heavy metal. Okay. And as I said, heavy metals, even if they're present at a very low concentration also, it will be very toxic to the body. So examples for heavy metals here are mercury, lead, bismuth, chromium, iron, copper, silver, gold, etc. Okay. So the metals that respond to this test are the ones which I just told right now. So what happens here in the limit test for heavy metals basically is, it is based on the reaction of this metallic impurities with hydrogen sulfide or sodium sulfide, and this reaction takes place in an acidic medium to form a brownish color solution. This is what is basically the principle also behind your limit test for heavy metals. These metallic impurities which are present in substances are usually expressed as parts of lead per million parts. It's also called in short form as ppm, parts per million. Okay, and the usual standard that you will be using here to compare it with is your lead. And Indian Pharmacopoeia specifies the limit as 20 parts per million. So this is the introduction to your heavy metals limit test. The apparatus that you're going to use here is your Nessler cylinder stand and the glass rod. The chemicals that you're going to use here are standard lead solution, hydrogen sulfide or sodium sulfide solution, dilute acetic acid or ammonia, dilute NaOH solution, acetate buffer pH 3.5, and then you're going to use sodium hydrogen sulfide, which is produced in situ. Do you know what do you mean by in situ?
No, ma'am.
Okay, in situ means, now supposing you're adding chemical A and B, okay, but without you knowing, there's something called as chemical C which has formed due to a reaction. You were not expecting it. It is something that was produced within the reaction. Okay, so that is called as in situ. Now you may be wondering, what is this? Previously and all, in all other limit tests, the chemicals required were just 2 or 3 in number. Whereas in this, ma'am has put how much? 6 chemicals which are there. Okay, don't worry. The Indian pharmacopoeia for limit test for heavy metals follows 4 methods. Okay, previously there were just one method for your limit test for chlorides, sulfates, and your iron, which we saw today. But for limit test for heavy metals, there are 4 methods which are being followed. We will see one by one. Is this image clear?
Yes, ma'am.
Yes, ma'am.
Okay, so this is method 1. Method 1 is used when the substances give a clear colorless solution under the specific condition. So here also you can see there are 2 tables, right? One is test sample and the other one is the standard. So we'll look at one after the other. So in the test sample, the solution is prepared as per the monograph. Now supposing you know that you're going to test paracetamol, then you're going to go to the monograph of paracetamol which is present in the Indian pharmacopoeia, and you're going to see what is the method that they have told to follow. And if it is method 1 that they have told to follow, the procedure also will be given as to how you're supposed to prepare the solution to do the limit test. So the solution is prepared as per the monograph, and 25 ml is transferred in the Nestler's cylinder. So till now, whatever we have been talking about Nestler's cylinder, we have used only a 50 ml Nestler's cylinder. Okay. Then this, whatever solution you have transferred into the Nestler cylinder, you're going to adjust the pH between 3 to 4 by adding dilute acetic acid or dilute ammonia solution. Why have I mentioned dilute acetic acid or dilute ammonia solution? What is basically acetic acid and ammonia? Dinesh, what is the nature of acetic acid and ammonia? Anyone? Pooja, Gujar?
Don't know, ma'am.
Ma'am,
Oh, no,
basic
ma'am.
nature.
Yes, Aisha?
Basic. Base.
What is basic? Acetic acid is basic or ammonia is basic?
Ammonia is basic.
Acetic
Correct.
acid,
As the name specifies, it is acidic in nature, right? You have the clue there itself, acetic acid. That means to say it is acidic in nature, whereas ammonia is basic in nature. Now, supposing your solution, when you're checking the pH, has a pH of 1, if you're going to add acetic acid, you're going to make the solution more acidic, okay? But you want the pH to be between 3 to 4. At that time, you're going to add dilute ammonia solution to bring the pH to 3 to 4. Now, supposing your solution is basic in nature and it has a pH of 10, then you need to bring down the pH to 3 to 4 because that is what is specified in the pharmacopoeia. So, at that time, you will be adding dilute acetic acid. So, since you don't know that substance that you have taken, whether you know it is acidic or basic in nature, you're going to first check the pH of it, and later, based on what is the pH that you have got, whether it is 1 or 10, based on that you're going to either add dilute ammonia solution or you're going to add dilute acetic acid. So whatever you're going to add, you have to bring the pH to 3 to 4. Okay, next step is, once you have brought the pH to 3 to 4, you're going to dilute with water to 35 ml. So you may be wondering, how is this ma'am is telling to do in Nestler cylinder? Ma'am showed a picture also of Nestler cylinder where there was only 2 markings, right? The marking was 25 ml mark and the marking was 50 ml. Now she's telling dilute with water to 35 ml. How do we do? So in such cases, what happens? You will have to take 2 50 ml measuring cylinders and you will have to do it in that, because they're specifying what ml, right? Otherwise you have to do back calculation. You have taken 25 ml, you may have added 5 ml of dilute acetic acid, So you need to add another 5 ml of water. So instead of, to avoid all this confusion, you can do it directly in your measuring cylinder and then transfer it into your Nestler cylinder. This way also you can do. So once you have diluted with water to 35 ml, you're going to add freshly prepared hydrogen sulfide solution, that is 10 ml. After that, you're going to make up the volume to 50 ml and allow to stand for 5 minutes. The same way you're going to prepare your standard solution as well. So you're going to take 2 ml of standard lead solution and dilute it to 25 ml with water. Then the same steps, you're going to adjust the pH, dilute and make up the volume to 35 ml. Then you're going to add 10 ml of hydrogen sulfide solution and again make up the volume to 50 ml, mix and allow to stand for 5 minutes. The only difference here is when you saw turbidity, you're going to keep a black paper behind your Nestler cylinder so that you can see the turbidity. The same will apply for your color solution which we saw for limit test for iron as well. But the difference here is you're going to take a white surface or a white paper and you're going to keep your Nestler cylinder on it and you're going to view downwards. That is, you're going to view into your Nestler cylinder from the top and you're going to see what is the color change. Okay, so the observation is the same for all the methods. The color produced in sample solution should not be greater than standard solution for the test to pass. If the color produced in sample solution is less, then the sample will pass. If the color produced in the sample is more than the standard, then the sample will fail the limit test. So now this is just method 1, wherein you have used hydrogen sulfide solution. Okay, remember this, method 1 we have used hydrogen sulfide solution. Next is method 2. So method 2 is used for substances which do not give clear colorless solution under specific condition. So method 1 gave a clear solution. Method 2 will not give a clear colorless solution, and that is why you are going to follow this method. So now this method, it is a bit lengthy. Okay, so please, as I am reading it out, please have a look at it. So under the test sample, you're going to weigh the specific quantity as specified in the monograph, and then you're just going to moisten it with sulfuric acid. After you are done with that, you're going to ignite on a low flame and you're going to completely char the substance. First of all, by adding H2SO4, that is your sulfuric acid, you are going to char it a bit, but you are going to put it on fire also. Ignite on a low flame till it is completely charred. Once it is charred, you're going to add few drops of nitric acid and again heat to 500 degrees centigrade. Now all of this is done in an apparatus called as a crucible. Okay, this crucible is made out of porcelain. After it is heated to 500 degrees centigrade, you're going to cool it down, add 4 ml of hydrochloric acid, and further you're going to evaporate to dryness. Once that is done, then again to that residue, you're going to add 10 ml of hydrochloric acid and you're going to digest for 2 minutes. Digest meaning you're just going to boil for 2 minutes. Once that is done, you're going to neutralize the solution with ammonia and make it just acidic with acetic acid. That is, again, you're going to adjust the pH between 3 to 4. The next steps that you see is similar as what you did in your method 1. You're going to dilute to 35, add 10 ml of hydrogen sulfide, then again make up the volume to 50 ml and allow to stand for 5 minutes. It is only the first step that is different. Okay, let's have a look at method 1. So in method 1, what you did, you took 25 ml of the solution as was there in the monograph, and then you just made the pH to 3 to 4. Whereas in method 2, what did you do? You took specific quantity of substance, then you added H2SO4, charred it, then again you heated it to 500 degrees centigrade by adding nitric acid, then you allowed to cool and add 4 ml of hydrochloric acid. Again you added hydrochloric acid and you boiled for 2 minutes. After this is done, you're going to adjust the pH to 3 to 4. Okay, so this is basically the difference between your method 1 and method 2, because the substance did not give a clear solution when you followed the method 1. Because it did not give a clear solution because you followed method 1, you're going to follow this method 2. That is by charring and boiling. Okay, the standard is prepared the same way. You're going to take 2 ml of standard lead solution, dilute to 25 ml with water, and the rest of the thing is the same. Is it clear? The way you're going to view is also the same. You're going to view downwards over a white surface. Did you all understand method 1 and method 2?
Yes, ma'am.
Okay. So moving on.
Yes, ma'am.
Okay. So moving on, we'll go to method 3. Now, when is this method 3 used? It is used for substances which does not give a clear solution. Okay, when you're following method 2 also, you're not getting a correct reading, but you saw that it gives a clear colorless solution in sodium hydroxide solution. Okay, so substances which gives a clear solution when you dissolve it in sodium hydroxide solution, those substances you're going to follow method 3 of limit test for heavy metals. So look at the procedure for the test sample. Solution is prepared as per the monograph and 25 ml is transferred, or you're going to weigh specific amount of substance, dissolve it in 20 ml of water and add 5 ml of dilute sodium hydroxide solution. Once you have added, you're just going to make up the volume to 50 ml with water, and then you're going to add 5 drops of sodium sulfide solution. After that, you're going to mix and set aside for 5 minutes. The standard is the same way. You're going to take 2 ml of your standard lead solution, but you're going to add 5 ml of dilute sodium hydroxide solution and make up the volume to 50 ml with water. To this again, you're going to add 5 drops of sodium sulfide solution, mix and set aside for 5 minutes. So now can you tell me what is the difference between method 1, 2 and method 3? It's very clear. What is the difference between method 1 and 2, which is like a group, compared to method 3? Just look at the picture. You'll come to know. Look at the slide. What is the difference that you can see? There's one chemical which is changed.
Lead.
I'm sorry, Trisha, go again.
Ma'am, we are using lead in method 3.
You are using lead there as well in method 1 and 2. Look at the rest of the chemicals. Are we using acetic acid or ammonia here?
No, ma'am.
Then we have used something else which we used in method 1 and 2.
Sodium
Yes,
sulfide and
correct.
hydroxide.
Correct. So in method 1 and 2, we used hydrogen sulfide solution. I told you people to remember it, right? I told you remember method 1 and 2, we're using hydrogen sulfide solution. Whereas in method 3, we are using sodium sulfide solution. Basically, both of them are sulfides, okay? But you're using 2 different sulfide solutions because you're following different methods itself altogether, okay? So this is the difference between method 1, 2 and 3. Let's look at the last method which is there under limit test for heavy metals. This is method 4. So where is this method 4 applicable? It is applicable for insoluble and characteristically colored sulfides of heavy metals. You have seen, you have taken your substance, dissolved it with the solution which is specified in monograph. You saw it didn't give a clear solution. Then you try to follow method 2 also. You are not getting the proper conclusion. Then you try to dissolve that substance in dilute NaOH solution. That is your method 3. Still you are not getting a clear solution. So finally you are left with no option because you see that your compound is insoluble in nature, you're going to follow method 4. Okay, let's look at the procedure for this method 4. Under the test solution, you're going to place 12 ml of solution prepared as per the individual monograph. To this, you're going to add 2 ml of acetate buffer, which has a pH of 3.5, and you're going to mix well. To this, later you're adding 1.2 ml of thioacetamide reagent, and you're going to allow to stand for 2 minutes. When it comes to standard solution, you're going to place 1 ml of standard solution. Okay, read the next point, next line very carefully. You're going to add 2 ml of test solution and you're going to mix. Okay, then you're going to again add 2 ml of acetate buffer, which has a pH of 3.5. You're going to mix well, and then you're going to add 1.2 ml of thioacetamide reagent and allow to stand for 2 minutes. You're going to compare the color as usual by viewing vertically downwards over a white surface. The color produced with the test solution is not more intense than that produced with the standard solution. Then you say that the sample passes the limit test. Okay, so basically the differences that you see here, or the principle that you can observe here, is in methods 1 and 2, reaction of the heavy metal ion occurs with hydrogen sulfide. In method 3, reaction of heavy metal ion occurs with your sodium sulfide. Okay, so in all of these 3 reactions, or in all of these 3 methods, it leads to the formation of your heavy metal sulfides. Okay, it's as simple as that. Heavy metal ion reacts with your sulfides to give the heavy metal sulfides. Okay, this metal sulfides remain distributed in a colloidal state and give rise to a brownish coloration. That is your end point. The color that you are going to observe will be a brown color. Method 4 is different, wherein it is based on the precipitation of relatively insoluble and colored sulfides. Okay, and as I said, when we saw under the chemicals required, we saw sodium hydrogen sulfide, and in the brackets I had written produced in situ, that is, it is produced within the reaction. So how is that NaSH, that is sodium hydrogen sulfide, prepared? Is it is generated by heating thioacetamide with sodium hydroxide. Okay, here also, in this case also, in method 4, a brown color is produced at pH 3.5 in colloidal form, which is stabilized by adding glycerin. Okay, let me go back to method 4. Can you tell me what is the difference between methods 1, 2, 3 when compared with the method 4? What is the immediate difference that you can see here? What is the immediate difference that you can see here? Siddharth, this is your first class, right? Siddharth Gowda, yes.
Yeah, ma'am, this is my first class.
Okay, and why did you join the this one class very late?
I am not in home, ma'am. I am in outside.
You are not in the group?
No, ma'am.
Okay, please take number of your class representatives. Okay, today Aisha is there, Sindhushri is not there. Okay, so you please contact Aisha, or Aisha, you can ask Shweta ma'am and take Siddharth's number and please add him in the main group as well as our pharmacochemistry group, probably subsequently in the other groups as well.
Sure, ma'am, I'll do that.
Okay. Yes, so now coming back to this, tell me what is the difference that you saw between methods 1, 2, 3 when you compare it to your method 4?
Ma'am, we are using thioacetamide reagent and acetate buffer of pH 3.5.
That's correct, but there's one major difference. What is it? Okay, I'll tell you. You are not making up the volume here. Are you making up the volume to 50 ml?
No.
Yes, so that is your major difference. You are not making up the volume at all here. You're just following the instructions which was told. Place 12 ml of solution, add 2 ml of acetate buffer, and 1.2 ml of thioacetamide reagent. And when it comes to standard, you're taking 1 ml of standard solution, and whatever is your test solution, no, from that you're taking 2 ml. Then you're going to add 2 ml of acetate buffer and 1.2 ml of thioacetamide. Nowhere are you going
ma'am.
to make up the volume to 50 ml. So that is the difference that you should remember when it comes to method 4. Okay, this is thoda hatke se, right? This is a little bit different. So you should remember this method 4 a little bit easily. Okay, moving on. This is limit test. Next is limit test for arsenic. So before I start with limit test for arsenic, is there any doubts with your limit test for heavy metals?
Ma'am, I have some doubts.
Yes, tell me.
Ma'am, in method 3, we are using in method 3 we are using sulfide solution, and
Yes,
method 2 we are using hydrogen sulfide, and ammonia why we are not using, ma'am, in method
we are
3.
using. Wait, let me go back. Okay, you are not using here because you are already taking an alkaline solution. Okay, if you see solution is prepared as per the monograph, and what is method 3 you're going to follow? Using a sodium hydroxide solution. Okay, so this is the reason you are not going to use here. That's why you're not
Okay,
using.
ma'am.
Okay, any other doubts?
No.
Yes. Any other doubts from other students?
No, ma'am.
Okay, we'll move on to the next one, that is limit test for arsenic. Okay, now if you look at here the apparatus, is it the same that we have been using? Till now we finished limit test for chlorides, sulfates, iron, and we finished heavy metals. In all of this we used Nessler's cylinder, we used a Nessler's cylinder stand, and we used a glass rod. Are you seeing the same names here? No. We're using something called as, yes, we're using something called as Gutzit apparatus. Okay, this is your main apparatus when it comes to your limit test for arsenic. There's a diagram as well. Okay, so when you get this question, usually you will get a question on the Gutzit apparatus itself. Okay, and then the procedure. This is what you will usually get under this limit test for arsenic. Okay, let me skip the chemicals required as time is less, and there's a video also which I would want you people to see because that explains even better than me explaining it. Okay, so this is your Gutzit apparatus. Okay, so on the right you have your normal glass apparatus. Left side is the diagrammatic representation of the same. Okay, is the image clear, the one on the right?
Yes, ma'am.
Yes, ma'am.
Okay, so you can Google this as well, you know, so that you can see it a bit clearly. You can just type in the word Gutzit apparatus and you can look for the images. So this is basically a Gutzit apparatus. You can see that it's a very small, wide-mouthed bottle, okay, and it has a 2.5 mm neck into which you are adding your glass rod type. It's a glass pipe, okay, which has an internal diameter of 6.5 mm. Okay, so the video will explain it a little bit more clearly for you people rather than me just telling, and you know, the video takes it part by part to make you understand even better. Once the video starts, I want you people to tell me whether you can hear it. You can see it, right?
Yes, ma'am.
Yes,
We
ma'am.
can see it.
Yes, ma'am.
I think I'm having a little bit of network issues. Okay, it's not sending. It's not playing properly.
Subscribe our channel Farmers. Arsenic limit test apparatus is consist of 120 ml capacity wide mouth bottle fitted with a rubber bung through which passed a glass tube of approximately 20 centimeter and 6 to 8 millimeter diameter is used. One end to this tube is constructed like that of pipette with 1 millimeter diameter having a hole of 2 millimeter diameter. When the bung is inserted in the bottle containing 70 ml of liquid, the constructed end of the tube should be above the surface of the liquid and the hole in the side is below the bottle. The rubber bungs, about 25 millimeter, each with a hole bored centrally and through exactly 6.5 millimeter in diameter, are fitted with a rubber bung or a spring clip for holding them tightly in place. The glass tube is lightly packed with the cotton wool, previously moistened with lead acetate. Surface of the cotton wool is not less than 25 mm below the top of the tube. The upper end of tube is then inserted into narrow end of one of the pair of rubber bungs to depth of 10 mm. The tube must have rounded off end. A piece of mercury chloride paper is placed flat on the top of the bung and other bung placed over it and secured by means of the spring clip in such a manner that the holes of the two bungs meet to form a true tube 6.5 millimeter diameter interrupted by a diaphragm of mercury chloride paper. This is called as a gadget apparatus or apparatus which is used for arsenic limit test.
Okay, so was it clear?
Ma'am, it was not that clear. How about you send us the link of this video in the group and we can check it out?
Yeah, sure. I'll surely be sending it. Okay. So let me also try to explain with the image here. Okay. So now this is your Gutzit apparatus, and this is the apparatus that you will be using for your arsenic limit test. Now the apparatus consists of a wide mouth glass bottle. Okay, and the capacity of this bottle is 120 ml. It has a mouth of about 2.5 centimeters in diameter. Now rubber bung is nothing but like your cork which you use, no? That is called as a bung here. What they keep on referring to as bung is nothing but your rubber cork type. Okay. So this bottle is fitted with a rubber bung through which a glass tube is passed. The length of this glass tube is 20 centimeters. Okay. And it has an external diameter of 8 mm and an internal diameter of 6.5 mm. The tube, as he said in the video, it is constricted in the lower part, okay, and it has a diameter of just 1 mm. Now, when in the video, when they showed, the 2 mm hole was not visible. They had not, shown it in that animation. But here in this diagram, you can see there is a hole, okay, and that hole is 2 mm in diameter. It should not be less than 2 mm. So next, coming to the glass tube, the upper end of the glass tube has been fitted with 2 rubber bungs. Okay, here in this right side image, they have just shown 2 glasses, right? They've just shown 2 glass tubes which is held together by a clip. But in reality, it is held by, this apparatus is not most commonly used. But the one which I had used in the previous college was made out of rubber bungs itself. So the upper end of the glass tube has been fitted with 2 rubber bungs. The rubber bungs diameter is 25 mm. Okay, but the hole that is created, which is there, is of exactly 6.5 mm. So as you remember, what did I say is the internal diameter of the glass tube? That is also 6.5 mm. So therefore, the rubber bungs which you are using will also have the 6.5 mm hole. So one of the bungs is fitted to the upper end of the tube, while the second bung will be kept on top of it. So you need these bungs to be, stable, right? It needs to be in place when this reaction is going on. So that is why either you're going to use rubber bands or you're going to use a spring clip, so that the gas which is evolved in the bottle will pass through the tube. Okay, in between the rubber bungs which is present in the glass tube, you're going to keep your mercuric chloride paper. Okay, so this you will understand better once I show you the procedure which is involved. Sorry, so this you will understand better when I tell you the procedure. So let me go to the procedure. You know what, I think if I explain the procedure, then again it will be hushed up. I'll not be able to complete it. So how about I explain you the apparatus once again, okay? And I'll send you the link of this video so that you can understand it even better. Meanwhile, I had Prashant who texted me here separately. So what is the book, ma'am, that we're supposed to follow? You can follow G.R. Chetwal. Okay, I had sent it to Aisha, I guess. Aisha, can you please share it in the chemistry group?
Yes,
The
ma'am,
images
sure.
which I had sent you. Okay,
Yes, yes.
so she will send you the image. You people can go ahead and purchase it as well, but my advice would be to not, spend unnecessarily. So once you start coming here, once the offline classes start, you can get the book issued in your name from the library, or probably you can refer from it and prepare your own notes. Okay, so this would be my advice. Don't just go into spending money to buy textbooks when you can actually refer it from the library. Okay, so you can go through that as well. So let me again explain you. The bottle that we are using is made out of glass. Okay, its capacity is 120 ml. The neck of the bottle is 2.5 centimeters in diameter. So in this, you have a rubber bung or a cork that will be fitted. Okay, and through this cork, a glass tube is passed. The length of this glass tube is 20 centimeters. It has an external diameter of 8 mm and it has an internal diameter of 6.5 mm. So at the top of this 20 centimeter long glass tube, you have 2 rubber bungs. Now one rubber bung is fitted to your glass tube, whereas the other rubber bung will just be held over the first rubber bung. Okay, so because these two have to be kept in place and it should not be moved, you're going to use rubber bands, or you're going to use a clip called as a spring clip, which was shown in the video. Okay, so this is basically your gut seat apparatus. So in the next class, that is on Friday, I'll explain you what is the procedure and I'll explain you what is the principle involved in this arsenic limit test. Is it clear?
Yes.
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, so let me just take your attendance. Aisha,
Yes, ma'am, I'm here.
Meghna,
Present, ma'am.
Meghna, yes, Dinesh,
Present, ma'am.
Mutturaja is not there, right? Komal,
Present, ma'am.
Yashwant,
Yes, ma'am.
Siddharth, Sachin, Pooja Gujar.
Present, ma'am.
Dear, tell me, is your name Gurjar or Gujar?
Gurjar, Gurjar.
Okay, because in the list that we teachers have got, it is given as Gujar.
No, ma'am. Gurjar.
Okay, fine. Harshavardhan, he has not come today. Trisha,
Present, ma'am.
Prashant,
Present, ma'am.
and Pooja and Sindhu Shri are absent, right?
Yes, ma'am.
Okay, so I'll see you in the next class.